Okay. Here we go. Off we go. I did not know how much knowledge you guys have of this subject matter, but I will tell you this. If you look at this sheet right here, this is something that we need to be excellent at by the time we are done, and this summarizes everything if you look at the document I have in front of you. It says decision tree for finding all possible roots of a polynomial, meaning you have to be able to find the solution to everything, not just quadratics, but cubics, quartics, so on and so forth. We will learn how to use this. I give you all the factoring methods, and I also tell you how to use the rational roots theorem. Has anybody ever heard of the rational roots theorem? Do you remember using P's and Q's? A little bit. So Samantha remembers. Samantha, do you remember taking your P's and dividing by your Q's and looking for possible things and plugging them in? How about synthetic division? Do you remember that? Okay, those are things that you, believe it or not, had last year. Now, we will review them all, but we will want to master it and be very, very good at it. Today, we're going to look at all things graphical. Flip the sheet over, look at this part. We're going to look at graphs of polynomials. First degree looks like this. Whoop. I will do positive in red, and I will do negative in blue. So that would be if it's positive. If it's negative, it goes down. First degree polynomial. Everybody agree? What does the second degree look like? A parabola. Second degree is a parabola. That would be positive, and that would be an example of a negative. And we determine positive or negative by the lead coefficient in front of the x squared. Anybody know what a third degree looks like? A cubic. Third degree looks something like that. If it's positive, it starts down, it finishes up. How about if it's negative? Yep, just the opposite. It will start up here, and it'll finish down like that. How about quartic? Fourth degree. Look at what's happening here, okay? This has a min or a max, right? One or the other. Does the line have any? No. So this one has none. How many min or max does a parabola have? 1. How many min or max does a cubic have? 2. So how many is a fourth degree going to have? 3. How about a fifth degree? Very good. You got the idea. It's 1 less. 1 less. We'll address that in a second. So a fourth degree polynomial, it's going to start up. It's going to have 1, 2, 3 bumps to it. Instead of bumps, we will call them local extrema. Local extrema. Min or maxes. That's what it is. If it's negative, it's going to look something like that. Kind of like a W. And if it's a fifth degree, then it has 4 of them. Now, you may say to yourself, there's no way we could ever learn how to graph those. Yeah, you can. You'll learn how to graph all those by the end of today. You'll be able to do it very well. It's something where you take it home over Thanksgiving. You show your grandma and your aunt and uncle, and you're working on your homework. And they see what you're doing, and they understand lines. But after that, they're like, holy cow, you must be really smart. See, I am. I'm really smart. And they're so proud of their smart little, well, whatever you are, granddaughter, whatever. So anyway, we move along, but that's the idea. Do you understand the family of polynomials? We could continue on. The trend continues, 6th, 7th, 8th degree, but we're going to stop really at 5th. Now, here's what happens. Oh, I lost it again. My printer doesn't capture all this information, so I think I have a condition right here as x approaches negative infinity and as x approaches positive infinity. Is that what I have? Very good. Now, you got to follow me here, okay? Don't get lost. N, the power, is odd. We're going to look at our odd functions first, odd powers. And we're going to say we're going to look at the positive ones to start with, okay? So here's what I'm looking at. I'm looking at this one, and this one. Okay? Let's look at the positive ones. As x approaches negative infinity, what does the y value approach? If I were to drag this, if you look at the red one, you guys, this red graph, okay? If I were to go all the way to the left over here, what would happen to this value? Would it come back up? Would it continue? Y value is going to go down. Yeah, as x goes to negative infinity, y goes to negative infinity, meaning it continues to drop. So the condition is this. As x goes to negative infinity, y goes to negative infinity. Let's try the other way, okay? You can pick any odd function. We'll go to our cubic. As x goes, I'm looking at the red one, as x goes to positive infinity, what does the red part go to? Yeah, the y value goes way up to positive infinity as well. So y goes to positive infinity. Now, what if I switch it around? What if I make n negative? Oh, I'm sorry, n is odd, but what if I have a negative value? So I switch it up, okay? Let's look at the odd functions. Look at this one right here. Look at this blue one, okay? If it's negative, if x goes towards negative infinity, what does this go towards? Positive. And then we'll try the other part of it. If x goes to positive infinity, what does this blue part go towards? Negative infinity. So the idea is this. Odd functions start and end in different places. Their end behavior is different. And I will really call it, as I said, end behavior. That's what this stuff is. Okay? That's what it does as it goes towards positive or negative infinity. That's what the graph, it goes towards something, either positive or negative infinity for polynomials. Okay? Now let's look at our even functions. Okay? We'll look at, I'll draw a smiley face for these so they look different. So as we look at these even functions, okay, and we'll say that we'll look at the positive ones first. As x goes towards negative infinity, y goes towards positive infinity. As x goes towards positive infinity, y goes towards positive infinity. Yeah, so if it's a positive function, doesn't matter whether you go to negative or positive infinity for x, y is always going to go towards positive infinity. However, let's look at the quartic one here. Let's say it's a negative one, it's upside down. If x goes towards negative infinity, what does the y value go towards? Negative. And if x goes towards positive infinity, y goes towards negative. Yeah, it keeps on dropping. So even functions, they start and end in the same place. Okay? They start and end in the same place. And the last thing I want to do here is identify what we did before, is talk about the local extrema. Again, if it's a first degree, it doesn't have any extrema. If it's second degree, it has 1. Third degree has 2. Fourth degree has 3. Fifth degree has 4. So, given a polynomial of degree n, there are at most n minus 1 local extrema. We'll call it min and max. The study of the minimums and maximums are extremely important in furthering mathematics. I think you guys understand why. We just came out of a study of optimization where we tried to maximize profit. We tried to maximize the area of things. And so maximizing is good because it's efficient. It's efficient. And so that's why we want to know the nature of these things. We will understand these min and maxes a lot more when we get to calculus. And we'll understand what goes on. Okay, go to the other worksheet that I handed out. It looks like this. And what we want to do is we want to be able to make these graphs. And first thing you need to do is you need to identify degree, then the number of roots, and I would say I would say the direction. So that's going to help us. The first one, can you identify the degree of that polynomial? X minus 2 times x plus 3. It's a second degree because you have x times x makes x squared. So this is going to look like a parabola. Then let's identify the roots. Roots, solutions, and zeros all mean the same thing. These are already factored all for you. So we just want to sketch a graph already looking at them factored. What's the first one here? What are the roots here? 2 and negative 3. So I plot them. Negative 3, positive 2. Now, the direction. This is an even-powered function. Does it start up and finish up, or does it start down and finish down? Starts up, finishes up. So I draw it right through there. Piece of cake upside down. Now, everybody said, do we know how low that goes? No, we don't. We could do negative b over 2a and figure out the vertex, but we've said that we're good enough at that where we don't need to do it all the time now, okay? We're not going to worry about that right now. We're going to worry about getting the general sketch, the general shape. Okay, the next one, what degree is that? It's a third degree. I'm going to write third, 3 right there for third degree. What are the zeros? What are the solutions? Negative 4, positive 1, positive 5. We'll mark it. Does this seem new to you guys, or does this review? Okay. You guys are my guinea pigs first year around. You know that. It's odd, so it's either going to start down and finish up, or start up and finish down. One of the two. Which one is it? Why? Because it's a negative. So if you were to multiply this out, you get x times x times x would be x to the third, and it would be a negative. So negative x to the third. So it's going to look like this. Starts up. I have 2 bumps at most. Not always, but we could end up with none or 1. But you just get those 2 bumps. That's it. That is none. Technically. You couldn't have 1. It's going to decrease by 2 each time. That's another study for another time, though. Okay, let's go to number 3. What degree is this? Third degree. What are my roots? Good. So I got 0, 1, and negative 5. So 0, 1, negative 5. I like this stuff. I think this stuff is fun. When I saw this section coming up, I got pretty excited. I think that this is neat stuff. Maybe you do too. Okay, so it's odd. So is it going to start down, finish up, or start up, finish down? Very good. Odd or even by the number of x's. So we got 1, 2, 3 x's. So it's odd. How do you tell that? You got to know by the previous thing we just looked at. So if you look at all the odd ones, starts down, finishes up if it's positive. Starts down, finishes up if it's positive. Starts down, finishes up if it's positive. If it's negative, starts up, finishes down. Starts up, finishes down. Starts up, finishes down. That's what you got to be able to think of. So if you got to look back at the sheet, so be it. But you guys, this graphic organizer front and back, you want to bring that every day for the next 3 weeks here. We're going to look at it. You're going to know it inside and out, so it's going to be just in your mind. Okay? Buy a bunk bed. Put it on the ceiling. Okay. Number 5. I want to skip. We're going to get back to 4 and 6 here in a second. Number 5. How many solutions there? What degree is it? It's a 4th degree polynomial. There are 4 x's. So I'm going to draw my little graph here. And what are my solutions? Yep. So -5, -3, 3, and 5. Now, is this, if we were to multiply this all out, would we get a positive polynomial or a negative polynomial? Why? Very good. Parker sees it. He says positive x, negative x, positive x. So he understands that that makes it down. It's going to be negative, I mean. And if it's fourth degree, that means it's going to start down and finish down. So as I draw this, start down. What? Let me draw it real quick. Morgan, can you ask your question again? You sure? First time for everything. All right. He's got great advice about. When I need advice for how to do tricky stunts on the high jump mat, I go to Tyler right away. That's when I go to Tyler. Okay. Number 4. This is trickier. This is where we're going to have to get back to our graphic organizer. What degree is this? Third. How do you know third? Very good. Squared into that one, so this will be a third degree. Now look at this. What are your zeros? I got a double root at -4, don't I? Uh-oh. How do we draw it through -4 twice? Go back to your graphic organizer on the other side. Right here. Single root. Passes through. If it's a double root, it just touches tangent. I'll show you what that means. And if it's a triple root, it flattens. I don't know if that's how you spell that. And passes through. So if you look at this graph below here, let's look at this really quick. This one right here is a single root. This one right here is a double root. See how it touches tangent, bounces off? That's what a double root looks like. This is a triple root, and this is a triple root, where it flattens out and passes through. That's what we have to be able to model when we draw our functions. It's that type of behavior that we want to be able to model. So that kind of shows you an example. So let's look back at this one. Okay? We got -4 and you got 0. Is it going to start up and finish down, or start down and finish up? Start up and finish down. Single or double root at -4, right? So I come down and I touch tangent. I bounce off and pass through 0. Does that make sense? Look at your next one. What degree is number 6? 5th degree. What are my solutions? What are my zeros? 0, 0, and 0. And 4 and 4. So I mark 0 and I mark 4. 5th degree is going to start up and finish down, or start down and finish up. Start down and finish up because it's positive. What happens at that 0 spot? Flattens out and passes through, right? What happens at the 4? Touches tangent. That's what that looks like. If you graphed it on a calculator, it would look very, very similar to that. That's what's neat is that we can do that quick. We got through these two as well, second hour, and then a lot of people just finished it up, you know, the next hour, study hall or wherever they had it. But let's see if we can do 7 and 8 real quick as well. Get you guys going here so you can finish the other part up. I'd like you to work on the back side so we can be ready to go tomorrow to some more difficult things. But if you guys are getting this, you're doing really well. What degree is number 7? Fourth degree. Is it going to be positive or negative? It's going to be negative due to the negative x there. What are my zeros? 5, 2, and -1, -1. Very good. So I'll plot those at -1, 2, and 5. Real quick, let's draw it, and then you can go. This is a fourth degree, so it's going to start down and finish down. What happens at -1? A double root. It's negative due to this negative x right there. So that's what it does. See if you can get through some of these tomorrow, okay? This is homework, but you'll be allowed to check to see how you're doing. But try to get through this tomorrow. Try to get any of them that you can on the back side, okay? Good luck.